Pragya will get started. What I can do is I can have an introduction set up and then I'll hand it over to you. So,
Sure.
hey everyone, thank you for joining in on a Sunday evening for a webinar on JWT attacks, and Pragya will go much deeper in that. But let me give you a brief about the Pragya's journey, how she started off at Tata, working as multiple roles, and then working at one of our famous Indian cybersecurity companies, Safe Security. Moving on from there to Product Security and Academy, and now currently as a security engineer at PhonePe. She has a lot of experience in security, especially product security, and she can help us out over here by sharing some of her particular understanding of JWT attacks, and she can get more in detail through her webinar and presentation over here. Thank you for joining in, Pragya, and over to you now.
Thank you, Kathan, for the introduction. Thank you all for joining in. So let's begin. So today we'll talk about JWT, what is a JWT, and some general attacks that there are out there for JWT. So let's start. Yeah. So first of all, what is a JWT? So JWT stands for JSON Web Token. It's a base 64 URL encoded JSON object, and it is signed using a signing algorithm. It's widely used in API authentication and authorization workflows, as well as data transfer between clients and servers. Also, it is a stateless mechanism. This is actually the site where you can, look at some JWT. JWT is actually known as JWT, but we still call it as JWT. So I'll probably use JWT. So this is how a token looks like. You see there are three parts to it. First is the header. We have the header. Then the second part is this payload. And the third part is the signature. Okay, we'll talk more about it. Then this is the structure of JWT that I just showed on jot.io. So there are three parts: header, payload, and signature. So if you see any, if you are browsing any website, if you see any token that look like these, then it's probably a jot. Yeah. So this is my burp window. So I intercepted some application request, and I'll just show you how it actually looks. So this authorization bearer token. So this is actually a jot. So you'll see there are three parts to this jot. First is this part, the first dot ends the first part. So that is the header. So header usually contains the signing algorithm, which should be used for signing this token, and also what type of token it is, which is type. So if you see, this is base 64 URL encoded, and if you see its decoded form, you can see the type JWT and algorithm is RS256. So these are the only two information that this header holds. So this header can hold other information as well. The only mandatory field is the algorithm. There are many other fields, but they're all optional. We'll talk about them later. Then the next part is the payload part. This is the same token, and the second part is this payload part, which I've highlighted here. It contains the claims, and claims are usually statements about an entity. For example, a user. It's like a metadata about a user for whom this token is. So I have highlighted this, and this is also base 64 encoded. And if you decode it, you can see the data. You can see ID, username, email, role, all of this data, user data. And then we have some other data as well, such as IAT. This IAT means when was this token created. That's the epoch format of the time. Then we have created at is active. So these are all the claims that payload contains. There are many other claims that it can have. Third part of this token, this is the same token, is the signature. So you see the third part that I have highlighted. Now, if you see, this is, if I decode this, I don't see any information here. So this signature part, this is not base 64 encoded. That is why we cannot see anything here. So the signature part that you see, it is created by encoding the header and payload and then signing it using the algorithm which is specified in header. That's how we create this signature. Now, there are two types of JWT. So I think you may have heard about them, JWS and JWE. So JWS, which is JSON Web Signature, is typically the JWT only. So the token which we saw here, this is a JWS only. We can use both the terms JWT and JWS for this token. So JWS is typically the JWT only because header and payload are base64 encoded, and signature is, as we saw, say how signature is, it is not encoded. So that's JWS only. So it assures integrity, authentication, non-repudiation, but not confidentiality, because as we saw here, in the payload part, we can see all the data of the user, email, username, role, everything we can see. So JWS or JWT does not ensure confidentiality. So it's recommended not to store or not to send any confidential data in the payload part, such as passwords or any secrets. So that's JWS. Then the second is the JWE. This is actually encrypted. So token is also encrypted. So in our typical JWT, we don't see an encrypted token, but JWE, it's an encrypted token. So it allows to encrypt a payload so that only the intended recipient can read it. So this JWE also provides confidentiality, which is missing in JWS or JWT. So for the rest of the session, I will talk about JWS only, but I may use the term JWS and JWT interchangeably. Okay. Yeah, so let's see how the signature part of the token is created. So first of all, we create a signing input that is base64 encoding of header and payload. So we take the header, we encode it, we put a period in between, and then we take the payload and base64 encode it. So this will be my signing input. Once I get this string, I will hash it. So I'll use a SHA-256 algorithm for hashing it. Now remember, hashing is a non-reversible process. So if you hash something, if you take a string and hash it, the hash output cannot be dehashed to get the original string. So this is a non-reversible process. So I will hash this whole part, the encoded, the one that I got, the output of my first step. I'll use it as an input for my hashing. So I'll use SHA-256, and then I created a hashed string here. Then the last part is signing. So there can be two types of signing algorithms. We can either use symmetric cryptography or asymmetric cryptography. So symmetric cryptography is when you use a single token or secret key for signing and verifying. And asymmetric cryptography is when there is a key pair, such as there is a public key and a private key. So suppose this is an asymmetric cryptography. So in asymmetric cryptography, signing is done using private key and verifying is done using public key. So we will sign this whole output of my second step using my RSA private key, and then I'll get the signature. So this final section, this is the signature part of the JWT that we see. So JWT is header base64 encoded, payload base64 encoded, and the third part signature. Signature is this whole part that we created. And that's how my whole token gets created. Now that we have signed the token, when a server creates a token, we need to so when the receiving party receives this token, they need to verify the token as well, whether it is sent by the correct entity or not, or whether it's modified or not. So we need to verify the token as well. So for verification, so in case of asymmetric cryptography, we use public key for verification. So first step would be decoding. So we will base64 decode the header to verify the algo. So if in the previous slides, we saw that the header contains the algorithm. So that algorithm specifies that this particular algorithm, whether it is RSA or HVAC, should be used for verifying this token. So once the receiving entity receives the JWT, they will decode the header to find what is the algorithm. Now I got the algorithm as RSA. Second step would be to create the signature using the public key. So I have the public key. So I'll create the signature again for the received token. Then once I've got the signature, so we'll term that as calculated signature. Then once I've got this calculated signature, I'll verify this signature with the original signature. So the JWT that I got, it also had a signature. So I'll verify my currently calculated signature with the original signature that was there in the token and see if they're same or not. Once this is done, we will also decode the payload and then verify the claims inside the payload if they're correct or not. And once we're done with all these steps, our token gets validated because we have verified the claims which are there in the payload section, and we have also verified the signature that nothing was changed in between during the communication, nothing was changed in the token. And this is the correct token, legitimate token. So we have verified all those things. Okay, now we know the basics of JWT, how signing is done, how verification is done. We can move to some common JWT attacks that happen. So JWT attacks usually involve a user sending modified tokens to the server in order to achieve a malicious goal. So the goal is typically to bypass authentication and access controls by impersonating another user. So JWT vulnerabilities typically arise due to flawed JWT handling within the application itself. So for JWT attacks, what we do is we try to send a modified token to the server and do some malicious activities such as impersonating a user or accessing resources that are not allowed to. And these attacks are actually possible because of flawed implementation, that's all. So if you're implementing JWT in your ecosystem, you just need to make sure that you're following all the best practices to prevent any kind of JWT vulnerabilities. Okay, let's start with the attacks. So first attack, I think many of you may know about this already. It's the non-algorithm attack. So we saw that the header part contains the algorithm, which tells the server that this algorithm should be used for verifying this token. So if an attacker is able to replace that algorithm with none and the server accepts it, then it is a possibility of non-algorithm attack. So since none means an unsigned token, we can also remove the signature part of our token while sending this. So if I'm an attacker, I will change the algorithm from suppose HS256 or RS256, whichever is already specified. I'll change that to none. And then I will remove the signature part because none effectively means that no verification needs to be done. None is no algorithm. And if the server accepts that and accepts that, does not reject the token, it means that this attack has been successful and there is a flaw on the server side only because it is not verifying the signature. So that is the first attack. And it has a CV as well. So that's the CV. Yeah, it's an old one. So nowadays, if you're using updated libraries for JWT, you won't find this issue there anymore. So the effective measure for this is to use updated libraries. So this was that. You can read about it later. Okay. This is the non-algorithm attack. Next is the algorithm confusion attack. So, JWT usually supports two algorithms for signing. One is HS256, that is the symmetric encryption, and RS256, which is asymmetric encryption. So HS256 is HMAC plus SHA-256. SHA-256 is my hashing algorithm. That is why HMAC plus SHA-256 is written as HS256 in the header part of the token. And RS256 means RSA plus the hashing algorithm, which is SHA-256. So that is why in the header, it is written as RS256 as algorithm. Now, when we are implementing JWTs, there are functions for signing the JWT. Then there are functions for decoding the JWT, and there is a function for verifying the JWT. So this algorithm confusion attacks, it happens because sometimes developers may confuse decode JWT function with HMAC shared. So this is an algorithm confusion attack. So you can see here the verify method, it relies on the algorithm parameter in the tokens header. So the verify function, it checks what header it is, what algorithm in the header it is getting for the token, and it just directly uses that algorithm for verifying the token. So the issue here is, as I already mentioned, instead of two different keys, I'm only using a single key here. Secondly, for RS256, if there is a private key and a public key, and public keys are verifying. In this case, if I use HS256, there is only one key, which is the RSA public key. RSA, in HS256, I'll use just my RSA public key for signing and for verifying, and hence this attack will work because I will use the same key for signing and for verifying. So the server will not be able to reject it. So that is how the algorithm confusion attack works. So for this as well, we have two series associated with it. One is this, it's a pretty old one in 2016. So in PHP Jose library, before 2.2.1, it was vulnerable to key confusion or algorithm. So it is also known as a key confusion attack. So if you're ever using this library, just make sure you are using an updated version for it. And there's another CV for it. Yeah. So this is this is what I was talking about in the earlier case, the confusion between decode and verifying. So if a dev is using a decode function, algorithm is not enforced in the decode function, and hence a user is able to switch between both the algorithms. You can read about these later. Okay. was the algorithm confusion attack. So we discussed two attacks so far: non-algorithm, which is non-algorithm, which is based on the header, tampering of header. Then algorithm confusion, again tampering of header. Now we'll move to the next one, which is weak symmetric keys. So in weak symmetric key, it's not a vulnerability as such. It is more about following best practices. So weak symmetric keys, if you're using HS256 to sign your tokens, you're using a weak symmetric key, as in with less entropy, insufficient entropy, or human memorable password, using an easy password or a key for signing and verified tokens. So that we call it as a weak symmetric key, because such keys are vulnerable to brute force attacks or dictionary attacks. So if you find an application where they're using HS256, you can at least try to brute force it to see if maybe they're using a weak symmetric key. I don't think a lot of applications might be using a weak symmetric key, but it's still, you never know. So you can use hashcat for brute forcing the secret key. This is the command. You just need to have a valid JWT. So if you are browsing any application or working on an application, you'll get the JWT from there, and you need a word list. Word list you can easily Google. If you go on Google or GitHub, you'll find a lot of word lists. So you can use this word list as well. Next, okay. So next we move on to header parameter injections. So far we have talked about algorithms and algorithms. First we have talked about algorithms, then we talked about the weak keys. Now we will see few new parameters in the header section of our token. So our header section of the token can have other parameters as well. So initially we saw only type and algorithm. We'll see a few more headers now. There can be other headers also, but these headers are all optional. That is why you might not see them a lot while working. So as it's mentioned, only the algorithm parameters are mandatory, all others are optional. So it's up to the application developers how they want to implement it, whether they want to include these headers or not. So yeah. Okay, we'll talk about three parameters. First is JWK, which is called the JSON Web Key. So it provides an embedded JSON object representing the key. So the key which is used for signing, it is a JSON object only. So if you ever see this parameter JWK in your token header, its value would be a JSON object, and that JSON object would be the key. So take note of that. If you ever see that in applications, or if you ever see that while working, you see a token which has JWK, its value is the JSON object, which is the key. So you actually got the key from there. Then we have another header called JKU. Its full form is JSON Web Key Set URL. So this JKU, it provides a URL from which servers can fetch a set of keys containing the correct key. So JKU is effectively a URL which points to the public key that it needs to use for verifying the token. That's JKU. JKU is a URL. JWK is the JSON object, JWK is the actual key. JWK is URL. And then third one we have KID, which is key ID. So key ID. So it's possible that a server may have multiple keys. So key ID provides some kind of an ID that helps servers to identify which key they have to use for this use case or scenario. So that's KID. I hope these three headers are clear. One is simply showing the key in JSON object. Second is the URL. Third is some kind of identifier which tells which tells the server that this particular key you have to use for this use case. So not the good thing. So the thing is, these headers can be exploited because all of them are used to tell the server which key to use for verification. So we can exploit all three of these headers because these headers uh, 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 help the server in determining what key or what token they have to use for verifying the JWTs. So all of them can be exploited. So we'll see some small scenarios how they can be exploited. Let's start with the JWK parameter. So JWK is the actual public key in JSON. So it represents a public key which can be embedded within the header of a JWT. So it's there in the header. Public key is there in the header only in JSON format. And this public key is then trusted for verification since it's already there. An attacker could exploit this by forging a valid JWT, by removing the original signature, adding a new public key to the header, and then signing the token using the private key associated with public key. So how to exploit this? So now we have a token which has a JWK header and a key in JSON format. What an attacker can do is, once they get the token, remove the signature part of their token, generate their own RSA key pair, sign that token again using their own generated private key, and then paste the public key, their own generated public key, in the JWK parameter. In this way, I'm telling the server to use as an attacker, my own public key for verifying the token which I am sending. And the token which I am sending is already signed with the correct private key, which is the one that is now pasted in the header. So that's how this attack can get successful if the server does not check whether the token is sending the right public key or not. And there is a CV associated with this as well. Let's see what it is. Yeah. So this vulnerability was there in the Cisco Node.js open source library before 0.11.0. It could allow an unauthenticated remote attacker to re-sign tokens using a key that is embedded within the token. So if you are using this library, Cisco Node.js open source library, just make sure you're using a later version than this. You can read more about this attack later. Let's move back. Yeah, so this was about JWK. The next one is the JKU parameter. JKU was the URL one where we just mentioned the URL. So JKU, it represents a URL which points to the JWKS file. So JWKS file means the JWK is public key in JSON object. So this URL points to a file which contains the public key in my JSON format. So it's a URL that points to a JWKS file which contains public key for verification. And this URL is embedded in the header. So suppose this is my header, this is my algorithm, my type, and in JKU, this is the URL. And in the URL, I am mentioning this path, this file contains my public key for verifying. So with this header, an attacker could exploit this by forging valid JWT, same process as the previous exploitation, remove the original signature, add a new URL, and then sign the token using the newly created private key, which is associated with the public key. So in JKU, we follow the same procedure as the previous attack, the JWK parameter injection. We follow the same process. As an attacker, I'll create my own key pair, remove the signature of the original token, re-sign the token using my created private key, add a link in the JKU parameter to my created public key, and then send it to the server. So sometimes JWK sets are exposed publicly via standard endpoint. So this is a standard endpoint where applications usually store the JWKS file, that is the public key. So if ever you are working on an application, you're doing some directory traversal or something, you can also look for this path. This might contain, or this might be exposed. So that's exploitation via JKU parameter. Cool. Let's move to the next one. So next one was KID parameter. So we have covered JWK, we have covered JKU. Now we'll move to KID. So KID was it was an identifier for identifying which key should I use out of a bunch of keys that might be there on the server. So first kind of exploitation that we can do with KID parameter is, so when the KID claim is present in the header, we can search the web directory for corresponding file or its variations. So just look at this header. So suppose this is my parameter KID, and this is the identifier of the public key. So key is pub key 123. So 123 would be the identifier where my public key is stored. So this could be a typical format for a KID. Yeah, so if you see this format, and you can try to search for this file directly in the web root. So if you're enumerating any application or directly traversing it, just you can first the URLs and see if you can find anything like this, anything like the format that is mentioned in the KID. So this is pretty straightforward. You just look for this file in the web root, see if there is any file which looks like this, and you'll get the key. Either by adding some extensions like PEM extension or directly searching for the file. If it is there, you will see it. So that's what we call revealing key through KID parameter. So next kind of exploitation that is possible with KID is path traversal. So since it looks somewhat like this, so if you can see, this is a path, and then this is an identifier. So whenever we see a path, we know we can try for a path traversal. So path traversal with KID, so it can be exploited to navigate through the file system. That's what we call path traversal. We just navigate through the file system. And you can also check for SSRF in this by changing the KID value to target specific files or services. So you can also try SSRF payload to see if you can access any other file inside the server, like typically. So for example, in Linux systems we have, and Windows systems also, we have some. So this is an example. So for example, this is a file proc.sys kernel randomize vs space. This is used in Linux systems, and it has predictable values like 0, 1, 2. So as an attacker, I can create a malicious token using secret value 0, 1, 2 and send it to the server. So instead of keys, pub key 1, 2, 3, I can maybe enter proc.sys kernel this, and this file may have a value of 0, 1, or 2. And if I enter this, the server will accept this, and my attack is pretty successful because it could either be using 0, 1, or 2, which is pretty weak secret values. This is a tool actually, jot_tool.py. It's a tool and it directly helps in exploiting this. So you can see Python, it's a Python tool, jot, then kit, and then this is the path dev null. Dev null also has values of 2, 0, 1, 2, I guess. And algorithm is HS256. So using this tool, you can directly try to exploit this. let's see the third kind of attack that is possible with the KID parameter, that is the SQL injection. So sometimes it is possible that the KID parameter is fetching the key values directly from the database. Now, if we know, if whenever we see that a value is being fetched from a database, we always look for a SQL injection. So that's how a SQL injection can also be possible. And you can just enter a payload like this. You can do a union attack and it may be successful. So it all depends on how you're enumerating, how good you're enumerating your application, how good you are enumerating your token and trying to find where it is fetching the value from where, either from database or from a URL. It's so in JWT, if you see, all these attacks, so the SQL injection, path traversal, these are all universal vulnerabilities in web that we usually have. And in JWT, we are only we are using these vulnerabilities only based on the situation or based on how the token is actually working. So these are universal vulnerabilities only, and we are just using them. So if you see a path, you try for path traversal. You see a database fetch, database operation, you try for SQL injection. Same way we do in web security. And same methodologies we apply in tokens also. I'll show you another example of this. So the fourth kind of attack we can do is OS command injection. You can even do an OS command injection in using the token. So there can be a scenario where the KID parameter specifies a file path within a command execution context. So you can also try for any command execution, OS command execution commands. So it could look somewhat like this: root res key secret 7.key. This might be the original path of my KID parameter. Then I added some OS command injection command cd and then starting a Python server. So this may lead to an RC. So it all depends on how good you are able to enumerate your token and how good you're able to understand where the token is fetching the values from or how it is designed. So these are the 4 different kind of things you can do with KID. So if you find anything else, if you find any other way from which KID is fetching the keys, just try for associated attack with it. It's just like web. Now, these all attacks were based on how we could tamper a header or how we could tamper some values in the headers. This is a different kind of attack called substitution attack. So in these attacks, these are attacks which are intended. So in these attacks, one recipient will have a JWT intended for it, and it will attempt to use it at a different recipient that it was not intended for. So that is the textbook definition for the substitution attack. What might happen is, suppose you have a server and there is an application and that application uses JWT. So the server provides that application a token for accessing the resource. Now what that application might do is the application might further be communicating with another application, and it might send the same JWT to the further connecting application, and that which should not have been allowed. So if such a scenario happens, it is called a substitution attack because it can lead an attacker to gain unauthorized access to resources. So as you can see, protected resource might then present that same access token to a different protected resource. So it is possible that the other application might need some other auth token for fetching a resource. But here what the application did was it provided the same access token, which the application accepted, and then the user gained access to the resource. So that is a substitution attack. The next attack is the replay attack. So replay attack, it's simple. So there is a EXP claim in payload. EXP means expiry, which defines the expiry for the token. So if the EXP claim is set to never expire, or suppose it's set to 10 years or 20 years, it is susceptible to a replay attack. So there is also an issue associated with it. So this bug was there in .NET. Yeah, so it was not throwing expired token exception in .NET Core. So what was happening in .NET was in the token, the expiry claim was not set, but they were expiring the token using code. But the thing was, it was not working because the token itself was not expired. So that was the issue with .NET. They have fixed it now. So just make sure you're using the right versions of your libraries and tools. Yeah. So this was all about some common JWT attacks. There are other attacks as well, which I cannot cover right now. But if you need to read about them, I have attached some references at the end of this presentation. You can go ahead and read them. Here I have only covered attacks for JWS token, JWS/JWT. But I haven't covered anything for JWE because JWE requires a separate other session or explanation. So JWE I have not covered along with so JWE has some different kinds of attacks since it is an encrypted token. So all the things that you saw here we could do, we cannot do it with an encrypted token. So these are only limited to JWS or JWT, not for JWE. So JWE is different, and maybe we'll talk about it sometime later. Yeah, so these were all the attacks. Let's look at a couple of tools. So these are some tools that I found. If you find any other tool which is more helpful, you are free to use it. And do let me know also if you find any other good tools apart from these. So this is the JWT tool that I showed in one of the presentations. It's an open source tool, and I think it checks for all the vulnerabilities. So if you're feeling lazy, or if you want to get done with your work quickly, you can directly use the tool as well. So just run this tool. You can go through the tool and you'll find the commands for all the attacks. So you can use this tool also. I found this helpful. It's a good tool. Then BurbSuite, you can use BurbSuite also for generating new tokens. So BurbSuite has few extensions, JWT editor or JSON or something. There are a few extensions in BurbSuite. You can use those for creating new tokens, for creating new key pairs, or for signing your token and all those things. Then another tool is Hashcat or John the Ripper. So if you're trying to brute force some secret keys, you can use Hashcat or John the Ripper. There are other tools as well. So just find the one which suits you best. This is not an exhaustive list. Okay. Let's look at some best practices for implementing our JWTs in our applications. So this is a very quick go through of it. I haven't mentioned anything in detail. It's just a few good best practices pointers that you can have it in your like you can implement while you're implementing the JWT. First of all, let's look at keys. So if you are using keys, just make sure that they're complex enough. They don't have low entropy. You're using high entropy keys for both symmetric and asymmetric, so they are not susceptible to any kind of brute force attacks. Then it's also good practice to have a scenario prepared in case any of your keys are compromised. Then keep the keys in a safe place. Do not try to hard code them in the source code. And Also, another thing is do not allow to set arbitrary signature algorithm by the sending party on the server side. So this fourth point is for the algorithm confusion attack. So to prevent the algorithm confusion attack, you can enforce the server to only use the signature algorithm, which is specified in the code, and to not allow the server to use any algorithm which comes from the user. So just make sure that you're hard enforcing the server to only use the algorithm which is meant to be used or intended to be used. Next, for header, so few good practices for header as well. Enforce a strict whitelist of permitted hosts for JKU header. So this is for header parameter injection using JKU header. JKU means mentioning, writing the URL which points to the key. So by enforcing a strict whitelist of hosts for JKU header, you can prevent JKU header exploitation. Then another thing is avoid sending tokens in URL parameters where possible. That's a common generic good practice. Then third is to make sure that you're not vulnerable to path traversal or SQL injection. So we saw that kid header parameter, it could either use a path to the key or it could either get data from database. So even if you are doing that, just make sure that you're not vulnerable to any kind of path traversal or SQL injection attacks. Then for signature, there are a few best practices for signature as well. So first is check if your implementation does not accept the non-signature algorithm. So just make sure, so this is for the first attack that we discussed, the non-signature algorithm attack. So just make sure that your implementation does not accept the none algorithm in the header. Second is check if your implementation doesn't accept any empty signature. So there is another attack where if you send a jot without changing anything and just by removing the signature, the server accepts it. I haven't put it in the slides, but it is there. So this second point or good practice is for that attack, that just make sure that your application does not accept any token without signature. Make sure that every token should have a signature. Otherwise, reject any token which does not have a signature. Third is for JWE. This is a generic good practice. That's why I put it. So if you are using JWE, which are encrypted JWTs, check that you are using safe algorithms and safe implementation of these algorithms. So why this is mentioned? Because since JWE is encrypted, there must be some encryption algorithms that must be there in play for them to work. So this is for those encryption algorithms. That algorithms should be good. Like they should not be old algorithms which are easily breakable. And you, even if you're using the latest or good entropy algorithms, make sure that your implementation is safe for them. Like you're using a safe implementation of them, because most of the attacks happen due to misconfigurations or insecure implementation. So make sure you're not implementing them in an insecure way. Then another fourth part is distinguish between verify and decode. Check if you're sure you are verifying the signature. So this fourth point is for algorithm confusion attack again, which I mentioned before. So there should be a distinction between verify and decode, because decode only means decoding the header and the payload. Verify means verifying the signature. So while you are developing applications, you may mistakenly miss out on verify and only keep the decode function. So just make sure that you're using both decode and verify functions. The next part is the payload part. What good practices you can follow for the payload part. First is check whether you're placing confidential information in JWS. So JWS is typically JWT only, which is base 64 encoded. So make sure you're not putting any confidential information because it is human readable. It is easily readable by decoding it. Then the next is make sure you're protected against a replay attack. So replay attack is when there is no expiry and you can use the same token again. So for example, there is a user who accessed an application and they accessed an application and their token does not get expires. So maybe suppose a year later, 2 years later, 3 years later, there is a man in the middle attack or the Wi-Fi pass or someone performs a Wi-Fi attack and get all the traffic. So it's possible that that user JWT token could also be retrieved. So, and then that attacker could use that token to access the application. So that's a far-fetched use case of a replay attack. So make sure you are protected against replay attacks also. So same thing, make sure that tokens have a sufficiently short validity period, which is the EXP claim, that is the expiry claim. This comes in the payload part. Make sure that there is some expiry to that token. It doesn't go on forever. Fourth part is the include the AUD or audience claim to specify the intended recipient of the token. This prevents it from being used on different websites. So AUD, so AUD claim. So there is so I mentioned about the substitution attack where you could use a JWT intended for one application at another place. So AUD can help in preventing such attacks. AUD means specifying that this particular JWT is for this particular application only, means audience, like who is the audience or intended recipient of that token. So you can include an AUD claim to make sure that substitution kind of attacks don't happen. So these were the some generic best practices for using JWTs. So to summarize, for preventing JWT attacks, make sure your implementation is correct. Make sure you're following best practices. Make sure there are no misconfigurations. So that's the whole gist of protecting against JWT attacks. Yeah. Also, there are some libraries. So whenever you are implementing JWTs in applications, you typically use some libraries. Like if you are creating an application in Node.js, you'll use some Node library for JWT. So there are different libraries. Usually we use libraries only. So read the library's documentation carefully. Check the vulnerabilities in the library you use, for example, in CV details. So I showed you some CVs, and those CVs, if you notice, all the CVs were in libraries only. So make sure that whichever library you are using, it does not have any vulnerabilities, or if it has some vulnerabilities, you use an updated version of that. Third is track new vulnerabilities in libraries that support JWT. So if you have an application and it already has a library, just Google search or see if any new vulnerabilities have come up. So keep yourself updated so that your application does not get those vulnerabilities. Yep. So that was on the generic good practices for JWTs. These are some references that I used, and these are for additional reading as well. So if you want to read more on few more vulnerabilities, or if you want to read more on JWE, you can access these resources. These resources are good. These resources are very good. So you can just read through them. Yep, that's all.
Awesome.
Any questions?
Thank you so much, Pragya, for this presentation. Anybody from the attendees who have any questions, please put down in the chat and Pragya can help you answer that. Pragya, are you able to see the chat?
Let me open it.
Sure.
Okay, there is a question. Once I found that Jot was using HS and Mode Sweep passive scan revealed the key. When I tried to decode or verify, it was saying wrong key. Um, I didn't get what issue did you face? Decode or verify, it was saying wrong key. You can't actually decode due to JWT libraries. So, with JWT libraries help you in implementing the JWT functions like signing a token or decoding or verifying. So, all the vulnerabilities that you saw, those arise because of using libraries only. Because we implement JWT using libraries. So, whatever issues you saw, those were because of misconfiguration or vulnerabilities in the library only. So if you're creating an application and you want to implement JWT, just make sure that you're using the correct library and look for all the vulnerabilities that may be present in that particular JWT library. Yep. Anything else?
I guess there's one more question, Pragya, from Yogi, and then some Bhuvan is asking for some references as well.
Okay, I can only see till Yogi question I answered for
Okay.
due to JWT library. So all the issues that we saw, those arise due to flawed implementation of library only, because we use libraries for implementing this system in our applications. Yeah, for references, okay. So for any references, you can use Portsfigure Labs. So I actually solved all the Portsfigure Labs and they enhanced my learning and understanding of JWT. So you can use Portsfigure Labs, just create a free account there. Those labs are very good. Then when you're testing any other domain and you see they're using JWT as auth, so what are the checklist of vulnerability that you test? Okay, so whenever I see JWT as auth, so I actually go by the list of vulnerabilities in the same order that I've written in the written in my slides. So first, you can look for what is the algorithm they are using, whether it's symmetric, asymmetric, um, or then you can enter a none payload, you can remove the signature and send the token. You can try that. It will show you whether the server is validating the signature or not. Then you can change the algorithm. If it is using RS, you can change it to HS. And yeah, you can also brute, and if it is using HS, you can try to brute force the secret token. So whatever vulnerability that I mentioned in the PPT, I try for those only one by one. And if it is using JWE, we have a different set of vulnerabilities, but I unfortunately haven't covered here. Yeah. In this case, yeah, you can try brute forcing. We said you can try brute forcing. You can try for none here. You can remove the signature and try if it works. Yeah, these are few things you can try. And in payload, I see, or you can, since header is not using any other parameters, so I don't think those other header injections would be any use here. You can try playing around with the algorithm. Yeah. Anything else? Sure. Thank you. Okay. If your secret key was compromised, you can you should just use a better key, maybe with high entropy, non-guessable, maybe a long string. You can use that, or you can switch to asymmetric algorithm as well. It's up to you how you want to secure it. And anything else, Kathan? Are there any other questions?
Perfect. I guess you have answered most of it. And what we can do now is, if there are no more questions, we can wrap up the sessions, and we can still open up the questionnaire after we post the session on YouTube. And if there are any questions there, we'll definitely get in touch with you, and we can virtually answer and send those particular answers over to the attendees.
Yes, absolutely. We can do that.
Perfect. Thank you, Pragya, for joining in. Thank you for your time. Thank you, everybody, for coming into this session, and hope everybody has a nice day ahead.
Thank you.